All right, well, if you notice it says in your table in 5-1, well, the only thing with that is we skipped 5-1, so we're going to kind of work on this. It says write each of the following in expanded form. Expanded form is when you write something out, like if you have 4 to the third power, that's saying 4 times 4 times 4. So this part here is what we call expanded form. So if we take these two examples and say 2 to the third power, and we're going to multiply that times 2 to the second power, that's like saying 2 times 2 times 2. So there's your 2 to the third power, right? And you're going to multiply that by 2 times 2. So how many 2's do you see here? 5 of them, right? You see 5 of them, right? So technically this would be 2 to the fifth power. We're going to do a couple more of these before you see if you see a pattern. So here you see 3 to the fourth power. So that's 3 times 3 times 3 times 3, right? And we're going to multiply that by 3 3's. So how many 3's you see there? 7. Okay. Again, see if you can see the pattern. Well, the bottom one, we got 6 5's. And 6 5's. So how many 6's do we have? 10. So let's answer the question down below. It says, what do you notice when you multiply two powers here with the same base number? A had the base number of 2, B was 3, and C was 6. What do you notice? What do we do? How do we come up with these answers? What do we basically do? Anyone see the pattern? Added the exponents. Good. What are the exponents? So, here's our first rule. So when we multiply two powers with the same base, notice the a's are the same, right? You add the exponents. So we're going to write it in here like this. So when you have two powers that are multiplied by the same base, your base number is exactly the same, you add the, thought that was someone from our class outside there. You add the exponents, okay? So obviously, instead of writing all this out like we did here, right? Wouldn't that be a lot shorter just to go, oh, 2 to the 3 plus 2 powers, 2 to the 5, instead of writing all this out. Because what if I gave you, I don't know, 7 to the 20th? You're writing a lot of 7's, right? So it's kind of a shorter way to do it by establishing this rule. All right. We good there? And we're going to pause the video. All right, now that's over. That's over. Let's try it again. All right, so part B says that we are going to rewrite each multiplication sentence as a division, right? When we take a division, right, we can take the product divided by one of the two multipliers, right? So I don't know. Let's do 3 to the fifth power, and 3 to the fifth power in expanded form is 3 times 3 times 3 times 3 times 3, right? And that's going to be over, I don't know, we'll do 3 to the third power. Okay. Well, what do we know when we have a number divided by itself? What is that number usually? 1, right? 5 divided by 5, 2 divided by 2. So if you notice that these 3's, 3 of them at least cancel on the top and the bottom, right? Leaving us 2 to give us 3 squared. Okay? So you can kind of think of this as 5 to the third. I'm sorry, 3 to the third. Let's try that again. 3 to the fifth over 3 to the third equals 3 squared, right? Just by canceling those out. So if we continue this pattern, if I say, okay, well, 4 to the 11th over 4 to the 6th gives us 4 to the 5th power. And 5 to the 12th over 5 to the 8th gives us 5 to the 4th power. So what do you notice here when you divide two powers to the same base? What's happening here? I have 4 to the 11th divided by 4 to the 6th gives us 4 to the 5th. What's going on here? Anyone see it? How are we ending up with these exponents being where they're at? What are you seeing? Stephen?
The exponents are subtracted.
You subtract them. Very good. You subtract them. And I know on my paper, I think on the board here it gets cut off. I think the rule is on the back of your paper, I believe, right? You guys open this up here. Let me see. Yeah, your rule is on the back of the second, or the top of the back page there. All right, so our next rule is, this will be a to the n. So again, if I divide exponents with like bases, we can subtract them. And that kind of makes sense, right? When we multiply, we added. Well, isn't the division the opposite of multiplication? So it makes sense we would subtract them, right? Because subtraction is the opposite of addition. Okay? So 2 rules so far. Okay? These rules you are going to have to know. Okay? By the way, the quiz on this will only be a half sheet of paper, so, but there's still, you got to know the rules. Okay, let's go to the back page. Everyone got this? Yeah? All right, well now, what do you notice here? The exponents are the same, but the bases are different. So if we expand this out, right, 2 times 2 times 2 times 5 times 5 times 5. Okay. Well, what is 2 to the 3rd power? What's 2 times 2 times 2? What's the actual number? 8. Very good. And what about 5 times 5 times 5? 125. And when I multiply 8 times 125, I get 1,000. Good. And if you look up on my place value sheet, find thousands, and you see the exponent, the base number below. What is that? Look for the place value thousands. 10 to the 3rd, right? Because 10 times 10 times 10 gives us 1,000, right? So I can rewrite this as 10 to the 3rd. So this is what we finished with when we started with this. See if you can see the pattern. Okay? Let's look at the next one. 5 times 5 times 6 times 6. So that's 25 times 36, right? When I multiply 25 times 36 is 900. Anyone know how we can write 900 in an exponent form? Anyone know what 900 is? 30 times 30, right? Which is 30 to the 2nd power. Good. So again, we started with this, and we finished with that box on the end. Anyone starting to see the pattern yet? All right, let's try another one. 10 to the 4th power, so that's 4 tens times 4 twos. Well, 4 tens is what? Well, 3 tens is 1,000. What's 4 tens? 10,000. Good. And then what's 4 twos? 2 times 2 times 2 times 2. 16. Now if I take 10,000 and multiply it by 16, anyone know what we get? 160,000. And just for the sake of time, you have to take my word on it. This is 20 to the fourth power. So what I want you guys to do is see if you can see what happens to the pattern when we have the same exponent but different bases. Blake? Very good. You multiply the bases and keep the exponent the same. Very good. Saw the rule. So let's move this up just a little bit so people are, I know people are still writing. So you are going to multiply the bases and keep the exponent. So how do we write that down below? Everyone got this? So I don't want to scroll too fast. We good? Okay, no one's saying no. So this will be basically A times B, and it's going to be to the m power. So we're going to multiply the bases, keep the exponent the same. Very good. That's usually the toughest one to spot. Okay, we're in part D now. Mary says that she can use the fact below to write a power raised to a power with a single base. So this is what Mary wrote. Okay. 2 to the third power, then she squared that. So she can say, well, 2 to the third times 2 to the third, because that's two of them, right? You're squaring this expression here. So there's two of them, right? So when I square 3 to the second power, right? Well, we know that 3 to the second power is what? 3 times 3. 9, right? So this is basically saying 9 times 9, which is 81, right? But another way that we can write 81 as a single base with a power, you can write it as 9 squared, or you can write it as this, 3 to the fourth power. So again, this is where we started, and this is where we ended up. I'm sure if we do another one, you can start to see the pattern. So 5 to the third power, well, 5 times 5 times 5 is what? Huh? 5 times 5 is what? 0.5. Times another 5 is 125. So this basically says 125 3 times. All right? And 125 3 times. Now I put some time into this one, so you're just going to have to trust me, is that number. And I can rewrite that number as a single base and an exponent of this. Ready? So again, we started here and finished at 5 to the 9th. Anyone starting to see the pattern yet? Raise your hand if you think you see the pattern. About 5? Okay. Let's do one more. We know that 2 squared is what? 2 times 2. 4. So we got 4 times itself 4 times. And 4 times itself 4 times is 256. Okay. And I can rewrite 256 as this. Two to the 8th power. So what do you notice when we raise a power to a power? Jacob? So he said the base stays the same, and you multiply the exponents. Good. So we're going to write keep the base and multiply the exponents. Yeah, I don't know what happened to this one, so I'm going to rewrite my rule. I think it comes out better on your paper than it does on mine. But you're going to keep the base and multiply the exponents. So to kind of fit that rule, if I got this, I believe it shows up on your paper, but it doesn't show up on my board, right? You got that? Right? So what we're going to do is we're going to take A, and then you're going to multiply the exponents. That's our rule. All right, so now let's go to the last page. So the last page has, in part E, it says, as he worked on problem 5.1, question C, Delmar made the following claim. So we've talked about this before in the very beginning, right? Anything raised to the 0 power is always 1. But look what he did with the negative. A to the negative 1 power, he came up with this. Okay? And if you noticed, when we were talking about negative exponents yet. But anything to the 0 power, so again, 5 to the 0 is 1. 10 to the 0 is 1. It could be a million to the 0 power. It's 1. Anything raised to the 0 power is 1. Okay, so that's another big rule that you got to have to memorize. Okay, so the negative exponent rule is actually, he's spot on. So let's say, for example, if I give you 4 to the negative 1 power, that's 1/4. 8 to the negative 1 power is 1/8. And 15 to the negative 1 power is 1/15. So if you see the pattern, okay, for each of these, how we wind up with each one, our rule down below is anything to the negative power gets basically put into the denominator. 1 over a to the m. That makes the exponent positive. Okay, so these are our rules that we gotta have to memorize and practice with. So the homework assignment for tonight is page 88, 2 to 11, and page 89, 16 to 21. So we hope you found this video helpful, and we're going to stop it right now.